Hey everyone, today we'll be solving LeetCode problem 104, maximum depth of a binary tree. This is another problem of the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given the root of a binary tree, and we want to return its maximum depth. We are told that the maximum depth of the tree is the longest path from the root to the farthest leaf node. So we know that, for example, in this image, the depth of the 15 here is 1, because it has no children. For this 7, similarly, its depth will be 1. The 20, which is the parent of the 15 and the 7, will have a depth of 2. This 9 here, which is the left child of 3, has no children, so it will have a depth of 1. And this 3 here, which is the root of our tree, has a left child, which has a depth of 1, and a right child, which also has children, and therefore has a depth of 2. Therefore, the depth of this 3 is going to be 3, because it is 1 extra compared to its right child. There are different ways of solving this problem. We can solve it with a depth first search or a breadth first search, but I'm going to solve it with a recursive depth first search because the code for this method is the simplest. It will have a time complexity of O of n, or linear, because we are running through each and every node once. What we will do is run through each and every node, and for each node run the same function, where we return the depth of the current node. So we know that for this node 3, its depth will be 1 greater than its child with the greatest depth. In fact, we saw that its height is 3 because it is 1 greater than its right child, which has a depth of 2. Therefore, for this function, what we will do is return 1 plus the maximum value that we obtain from recalling the function on both the left and right node. So we can have here 1 plus, and then move on to the left and right node. We know that for this 9, once again, it has a depth which is equal to 1 plus the maximum depth between its left and right child. Now when we reach its left and right child, we see that those are null nodes because 9 has no children. So our base case will be to return 0 if we have a null node. From this 9, we will return 1 plus 0 for its left child, and therefore it will be 1 altogether. We get to the 20, and once again here, we will return 1 plus the max depth between its left and right child. Its left child, 15, has no children, so for this, we will have 1 for itself, plus 0, and so we will have 1 as the depth for the 15. The same exact thing can be said for the 7. Therefore, when we pop back up to the 20, we saw that it will have a depth which is equal to 1 plus the maximum value between its left and right children, and that would be the max between 1 and 1. And therefore, that is basically 1 plus 1, or 2. We then pop back up to our 3, which is our root node, and we know once again, its value that we will return is 1 plus the max between the depths of its left and right children. And its left child has a depth of 1, while its right child has a depth of 2. Therefore, for this 3, our root node, we're going to return as its depth 1 plus 2 from the right child, which makes 3. And because the 3 is our root node, we will return 3 as our overall answer. So this is how our function will work, and we're ready to code it up. As I said, the code for this solution is going to be very simple and brief. What we want to do is each and every time call the same function, which is the one that's given to us, max depth, and return the depth of the current node. Now we have our base case where if the node does not exist, so I'm going to say if not root because we're given a root. And in this case where we have no root, we have no node, we want to return 0. In fact, in the case of a null tree, we want to return 0 because a null tree has no depth. Otherwise, what we want to do is return 1 for the current node plus the maximum between the depths of the left or right children. So we're going to recall the same function on the left and right children of the current node. So we're going to say self.maxDepth to recall the function. And in the first case, pass in the left node, the left child. So root.left. And we also want to compare it with the depth of the right child. So we're going to have self.maxDepth and pass in the right child. And we know that the current node will have one depth greater than the maximum between the left and right child. So this will complete our function, and it will just be continuously called until we reach the base case, which is when we have no node. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please subscribe to my channel. I'll see you on the next one.